Fusion is a hot topic in energy. Emphasis on the hot, since fusion is what happens when you bring nuclei together in a charged plasma. It has what's known as high energy density. In other words, you get a lot of bang for your buck. Fusion is dependent on the density, temperature, and the amount of time. If any of those variables increase, so does the output of the reaction. Getting nuclei to fuse is like trying to bring two repelling magnets together. It requires a lot of energy. High temperatures provide that energy, while density and time ensure those particles meet up. Scientists have tried many methods to make fusion on Earth a reality. Tokamaks, stellarators, reverse field pinches, spheromaks, and more. Out of all of these methods, tokamaks have advanced the furthest, so we're going to focus on it. Tokamaks use magnets and electric coils to confine extremely hot plasma, as in hotter than the sun's surface. The charges in the plasma interact with electricity to keep it in shape. But the more time plasma spends, the more prone it is to developing turbulence. Have you ever watched a flowing river and seen swirls of water? Plasma experiences these eddies too. What eddies do is transfer kinetic energy into smaller and smaller eddies until it's dissipated as heat. Excessive turbulence means excessive energy loss. Not only that, the waste products from fusion have to go somewhere too. If stray ions hit the walls of the tokamak, they could potentially damage the material. There's still hope though. Some of these problems have been decreased by developing new materials or changing the way plasma moves to decrease turbulence. With our over-reliance on fossil fuels and its devastating influence on the environment, making fusion work would be a boon, which is why there's no confusion. Fusion should have an electrifying future in energy.